Entity Data Podcast.
Hi, this is Daria from Entity Data, and welcome to Innovation Insights, a series of podcasts in which Entity Data picks out emerging technologies and concepts that are developed today and which we will think that will have a transformational impact on the world economy in the next few years. Today, we're looking at the rise of photonics, which could see us both going beyond the limits of silicon technology in computing devices and building ultra-fast, highly responsive networks. This is the key to a more collaborative and also environmentally friendly economy. So how far away is this reality of a world connected as never before? Let's find out.
We're living in a connected world. That's something all of us understand. How could we do business, download films and games, talk to colleagues while working from home, any of the things that are now a normal part of our everyday lives without connectivity? But of course, this dependency comes with its own issues. Everything we do online is leading to an exponential rise in data use, and that drives much higher energy use as well. Take one example that's been all over the news and not always for good reason. CCTV, or street cameras. At this moment, there are believed to be about 770 million of these cameras in operation worldwide. Each one uses the same amount of power as a conventional old-fashioned light bulb. That's 770 million light bulbs always on. And the number is growing all the time. But here's another example, the rise of AI. We're using these rapidly evolving systems to support a growing number of daily business activities. AI drives hyper-automation, enabling systems to run without human intervention. That saves time and in some areas raises quality. But these systems have to be powered and they use vast amounts of data. So does the industrial Internet of Things, those sensor arrays that collect data from machines, vehicles, buildings, pretty much everything and everywhere. We depend on them for making our systems more efficient and improving decision making. But they all increase the amount of data moved around every second of every day, and that takes energy, lots of it, in larger quantities every year. That's a problem. And it's made more serious because we're doing all of this through technologies that have their roots 50 to 60 years into the past. For example, the silicon chip, which is at the heart of all computing, and Internet protocol at the heart of networking. These technologies are now right at their operational limits, but the demand for networking and computing capacity just keeps on growing. That's where photonics comes in. Using light to transmit data is not a new idea. Introducing optical connections for broadband internet and audio applications has been a game changer across the world. Televisions and hi-fis have offered optical audio options for years, after all. Yet today, we only use this technology in a limited way. For example, to connect data centers, and for the last mile of communication from substations to offices and homes. The photonics revolution goes much further by using light in place of our current silicon-based processors. By putting photonic connections into computers and digital devices, as well as end-to-end across our networks, the limitations of the old-fashioned technologies we still use will eventually disappear. Processing speeds of individual devices will grow exponentially. Bandwidth will expand as new forms of optical connection with multiple cores in each cable are introduced. We'll see high-performance optical switches and new solutions for access point names, or APNs, which form the gateways between different protocols and generations of technology. The big question, of course, is how will this change operations and performance? The headline figures are pretty dramatic. By moving to an all-photonics network with photonics-based devices, we will see network power consumption 100 times lower than today. That means we will need only 1% of the power required today to do the same kind of work. Capacity in the network will be an estimated 125 times higher than today, and as for latency, that's expected to be 200 times lower, which means transferring data will happen in half of 1% of the time needed today. That gives new meaning to the often misused term orders of magnitude better performance. This really is transformational. It's also very necessary. The demand for data keeps growing relentlessly, yet the drive to reduce energy and carbon emissions also grows. We can't meet these two conflicting requirements without doing something very different, by using very new technologies. This move to a new networking technology is the key to the otherwise insoluble problem of higher data and lower energy at the same time. And there is one other benefit also. Photonics technology allows us to increase the intelligence of the network itself. By broadening and accelerating data flows, we can embed machine learning, immersive technologies, artificial intelligence, and remote collaboration more effectively. This is how we at NTT Data expect to make our vision of an intelligent, networked cloud become a reality. Now, how far away is this vision from realization currently? It's closer than you might think. The initiative is being driven worldwide by the ION Consortium, which stands for Innovative Optical and Wireless Networks. The founders were NTT, Intel, and Sony, but the team has now expanded to include businesses from networking, IT hardware, telecoms, and services. The concept's been proved, implementation is now starting, and we're very proud to be not just an early adopter, but first mover and prime innovator in this extraordinary, ambitious development process. It may be a decade before transformational change takes place, but we'll start to see the difference long before that. The original web changed the world. The new networks now in development will bring bigger changes with greater benefits still.
We're continuously working on original research and development into photonics and all other aspects of advanced networking. For more information about emerging innovations, please listen to the rest of the series of podcasts and download the latest thinking from our website. Please join us next time for more technology insights.